Welcome to the video lecture on coordinate system by Dr.R.J.Shelke, Associate Professor in Electronics Department at Walchand Institute of Technology, Solapur. Learning outcomes. At the end of this session, students are able to draw and explain different types of coordinate system. Students are able to represent different coordinate system and able to convert the coordinate systems. They can convert the rectangular coordinates into the cylindrical and cylindrical coordinates into the rectangular. The contents which we will cover in these lectures are introduction to the coordinate system, representation of rectangular and cylindrical coordinate system, conversion of coordinate system. The terms related to the coordinate systems are coordinate system, which is defined as a set of three reference directions at each and every point in the space. The origin of the coordinate system is a reference point relative to which we locate every point in the space. The position vector defines the position of the point in the space relative to the origin. These three reference directions are referred as a coordinate directions, and these are usually taken to be mutually perpendicular to each other. The types of coordinate systems are rectangular coordinate system, cylindrical coordinate system, spherical coordinate system. Rectangular coordinate systems are also known as Cartesian coordinate system. The three lines are called as a coordinate axis. They are labeled as x-axis, y-axis and z-axis. The orientation of this axis are shown in this figure. The direction of the z-axis is determined by the right hand rule. Curl the finger of your right hand around the z-axis in the direction of 90 degree. Counterclockwise rotation forms the x-axis to the positive y-axis. Thus, our thumb points in the positive direction of the z-axis. The three coordinate axis determines three coordinates plane. These planes are xy plane containing x and y axis, yz plane containing y and z axis, xz plane containing x and z plane. Now, if you want to put a point in the space, let A be the distance from the yz plane to the P, B be the distance from the xz plane to the P, and C be the distance from the xy plane to the P. We represent the point P by ordered triplet of the real numbers A, B, C. We call A, B and C as the coordinates of P. A is the x coordinate, B is the y coordinate and C is the z coordinates. Thus, to locate a point P, A, B, C, we can start from the origin and proceed as follow. First, move A distance along the x-axis, then move B unit along the y-axis, finally move C unit parallel to the z-axis. The point P is located in the space. The point P determines the rectangular box as shown in this figure. If we drop a projection or perpendicular from point P to the point on the xy plane, we get a point Q which has a coordinate A, B and 0. As it is lying in a xy plane, its coordinate for the z is 0. This is called as a projection of point P in xy plane. Similarly, R and S are the projection of the point P in yz and xz plane respectively. The point P, which is represented by the rectangular coordinates x, y, z, is located as the intersection of the three mutual perpendicular planes x, y and z. The unit vector related to these points are ax bar, ay bar and az bar, which represent the direction of that plane. The unit vector satisfies the following relation. If the unit vector cross product between the ax and ay, then the direction of the resultant vector will be in a z direction. Similarly, if the cross product of the unit vector y and z, then the resultant vector direction will be in a x direction. And if the direction cross product of the z and x axis, then the resultant vector will be in a y direction. Next, cylindrical coordinates. A cylindrical coordinate system is represented by the points r, phi and z, where r is the radius of circular cylinder, phi is also called as the azimuth angle, and z is called as a z plane. These all are the mutually perpendicular to each other. The unit vector related to the AR, A phi and AZ. AR is a unit vector in the direction of increasing r, A phi is a unit vector in the direction of increasing phi, AZ is a unit vector in direction of increasing z. Let us see the point representation in the cylindrical coordinate. As we are familiar with the polar representation, that which is represented by r and phi. Cylindrical point is nothing but a just addition of the z coordinate to the polar coordinate r and phi. Yes, this is a point which is representing the cylindrical coordinates r, phi and z. Let us see the conversion between the rectangular and cylindrical coordinate system. Using the trigonometry theory, we can determine the rectangular to the cylindrical coordinates and cylindrical to the rectangular coordinate. When the points are given in a cylindrical coordinate, to get to the rectangular coordinates, we can determine x can be determined as r cos phi, y as a r sin phi, and z is equal to z. If the points are given in a rectangular form, and to get the cylindrical coordinates, the formulas are r square will be equal to x square plus y square, or r is equal to under root of x square plus y square, and tan inverse of y by x. Z is equal to z. Using this formula, let us get some point. Pause this video, convert the point P 248 into the cylindrical. This point P is given into the rectangular coordinates. The answer will be 4.47, 63.43 degree and 8. Convert the point A, which is given in the cylindrical coordinates, into the rectangular. The answer will be 2.12, 2.128. As it is a 45, the two sides will be equal, x and y. The reference book which I had referred are Electromagnetic Engineering by William Hatt, and also by the same author, Problems and Solution in Electromagnetic. Thank you.